useful.
Yeah, I'm looking forward to playing with it. Great. So while Don's setting up, I will actually introduce Don. I'm not sure how many people here need Don to be introduced, but I will try. Don has done, as far as I can tell, everything in security, like crypto, binary program analysis, adversarial AI. I think misinformation with LLMs or something. Like, she's done a lot. And then last year, I've been learning, failing to learn to never disagree with her. So last year, she made a statement that basically red and blue are just going to get faster and faster, and it's going to happen faster than we expect. I thought she was wrong, and she was right. And so, as anyone who's tracking what's been happening, and like time to exploit and whatever, and the doomsday clock and everything. So I'm not actually sure what she's going to be talking about today, but I'm pretty sure I need to tell myself not to disagree with it. So with that,
thank you.
Do you have a microphone? Let's swap.
Do I put this here?
Whatever. Would you rather hold it, or do you want it in?
So I don't have to put it. Okay. Hi everyone. Thanks a lot for being here. Thanks a lot for the intro. Yes. So I'm Zhang Zhang from UC Berkeley, and I'm also faculty director of a campus-wide center called Berkeley Center for Responsible Decentralized Intelligence. And today I'll talk about towards building safe and secure agentic AI. Like Leo said, I work I have a lot of breadth in my work. This talk also have many slides. We'll see how many I'll get through. And so hope just people have fun. Okay, so I'm already excited about the fast advancement in frontier AI. And last year was called the Year of Agents. And this year, we do expect to see further explosive growth of agents. And with that, on the other hand, there's there's a broad spectrum of AI risks, as outlined in our recent reports, the International AI Safety Report, that's supported by close to 30 countries and UN and so on. So overall, as we deploy AI, as we all know, I think here I won't preach to the choir, it's really important to consider the presence of attackers for many reasons. And this time the stake is even higher with AI. So with that, then it's important that we build safe and secure agentic AI. And for this goal here, there are two main different categories of issues that I wanted to talk about if I have time. The first part is how to build secure agentic AI. Essentially, how do we protect the agentic AI systems from being attacked by attackers? And then the second part is how to mitigate misuse, how we can actually, for example, mitigate misuse of AI by attackers, and in the landscape of cybersecurity, in particular looking at the impact of frontier AI on the landscape of cybersecurity. So first, let me just briefly talk about the first part, building secure agentic AI. So everybody is really excited about agentic AI systems. These systems, they can observe the environment, get feedback, and then reason, plan, and take actions. So when we talk about safety, actually, I want to contrast two parts. One is LLM at the model level, safety, and there's the safety security issues of the overall agentic systems. So given the interest of time, I won't have time to talk about at the model level, the safety security issues. You can, welcome to watch my iClear keynote last year on this, that just mainly focuses at the model level. And for this talk, I'll focus on the agentic AI, the overall system level. So when we talk about agents, I think now also people are more familiar with now that it's not about just one thing. Agentic AI has a very broad spectrum in terms of the design space with actually many different dimensions. So in our recent overview paper, we actually lay out the overall design space of agentic AI across many different dimensions: input trust level, access sensitivity, workflow automation level, memory tool, and many different levels. And the overall points here, in our overview paper, we show that as we increase the agent flexibility across these different dimensions, we also significantly increase the attack surface. Again, given interest of time, I won't go into the details there. You can check out our paper for more details. So what this indicates is, as we design and build agentic AI systems, we need to consider this broad attack surface, and with different attack vectors and different security risks. So again, in our paper, we actually give a taxonomy for these different types of attack vectors and different threat models, and these will then result in different types of security risks in the agent and external environments. And all these essentially they lead to the key of the security goals for agentic AI, which includes in security we always talk about the CIA, confidentiality, integrity, and availability. And these, of course, they have their new instantiation and implication in the agentic AI space. And also I want to mention that there's one more that in particular that's important in agentic AI space that we call contextual security. So in this case, we want to ensure that the agent actions are aligned with user intent. Given the intelligence of the system, this is a particularly an important security goal in contrast to traditional software systems when we talk about security. So that's in our overview paper, as I mentioned, we lay out the agentic AI space in terms of the broad spectrum of the design space, and also the taxonomy of attack vectors, threat models, and risks, and so on. So now the question is, what do we need to do to actually build secure agentic AI systems that are actually resilient against attacks? So in this case, to achieve this goal, here essentially I will talk about two main types of two main stages. One is for evaluation and risk assessment, and the other one is how we do defenses. So first, in order to build secure agentic AI systems, it's really important to actually build a systematic evaluation and risk assessment. And then, so this will help us to better understand the risk issues in any given agentic AI systems. And then we need to, of course, build defenses to protect against these risks and attacks and so on. So first, let me briefly talk about evaluation and risk assessment in agentic AI. And the goal here is that we want to build automatic red teaming for agentic AI. And again, so in our paper, we also lay out taxonomy for automatic red teaming in terms of the scope and the different setup. So the automatic red teaming can be for different types of target agents, coding agent, web agent, computer user agent, general assistant agent, and so on, including, for example, OpenClaw. And then there are different types of attack goals and security risks, like the CIA that I mentioned. And then there are different threat models depending on what the attacker has access to in terms of its knowledge, in terms of its level of control, and so on. And then for automatic red teaming, essentially there are several parts to that. One is that we need to understand what is the agent state space for the automatic red teaming, and then how attacker can affect the state transition through the attack actions across the attack surface, and then cause the agentic AI system to transition into an attack success state. And to drive all this automatic red teaming, what we develop is essentially an optimization loop, where we essentially have the system, the automatic red teaming system, to go through this optimization loop where it can generate attack candidates, and then we'll launch the attack and then evaluate the candidate in the system and collect the feedback, and then we can then update the attack generator to then continue to this continuous optimization loop. And the optimization methods can include different types of methods. Of course, the simplest is you can do some heuristic search-based, and then you can also do gradient-based updates, and also you can do reinforcement learning, RL. So in our work, and then overall we can also the automatic red teaming system itself can also be essentially agentic system itself as well. So that's essentially what we have done. So here are some examples of our work in this space where we developed automatic red teaming system for different target agents with different attack methods that I mentioned that achieves a broad spectrum of different attack goals. And here are some examples. So leak agent is, so this actually is the first work using reinforcement learning for red teaming, where we're actually use reinforcement learning to build a red teaming agent for privacy leakage. So essentially, as what I mentioned earlier, through this RL loop, we can essentially automatically train and improve this red teaming agent, and in this particular case, to try to extract sensitive information from the model. And here are some examples where it's automatically then able to extract system prompts and also extract sensitive information from the training data as well. So that's a RL-based automatic red teaming agent development. Here's another example. Essentially, also this is the first end-to-end red teaming of black box AI agents, in particular for example, prompt injection attacks and so on. So in this case, we use black box optimization. So people have heard about, for example, alpha evolve and so on. So this actually was, you can think of it as alpha evolve for red teaming for black box AI agents, although we actually did the work even before alpha evolve came out and so on. So this, again, attackers only has black box access and can only modify the environment through which the agent interacts with the environment. So for example, attacker can inject malicious inputs, data into the environment, and then when the agent reads the malicious data, agent, for example, can get prompt and injected and so on. But in this case, we developed this using black box optimization loop. We continuously to update essentially the generated attack candidates and leading to successful attacks. So for example, this is an example of a real world web agent being successfully attacked using our system, where our system automatically then in the end generates a malicious review on the product review website that includes the prompt injection attack. And then when an agent is performing a task for a user, for example, to try to search for product review to make a product recommendation, in this case for like Samsung Galaxy screen protector, then the agent actually, when the agent reads a malicious review, it gets prompt injected and then leads the agent to then visit attacker's malicious website and then download malware and so on. So that's agent virtue. So this is our most recent work, agent exploits. This is the first multi-agent system for automatic end-to-end red teaming, and in this case for white box attacks. Here we assume that the agent actually has access, access to the code of the agents. And in this case, with agent exploits, we have multiple agents. We have an analyzer agent, and we have an exploiter agent. The analyzer agent uses various tools to analyze the targeted agent's code base and to identify the tools the target agent uses and the potential attack path. And then we have an exploiter agent that's then try to automatically generate potential attack inputs, and also identify and then also has advanced techniques such as context-aware generation, multi-injection collaboration. So when you combine this together, so this is an example of using our agentic system to find vulnerabilities and generate successful attacks automatically on open source coding agents. In this case, a GitHub issue resolving agents. So in this case, the analyze agent examines the coding agent's code to examine the target agent's architecture, identify untrusted input sources, and also flag sensitive tools the target agent uses, and then maps the attack path where malicious data can be injected into a GitHub issue, and then when the target agent consumes this, it can then be attacked and leading to the target agent to run certain malicious code injected by the attack and achieve the attack goal. And so that's the attack path. And the exploiter agents then takes this attack path and try to generate then candidate attack inputs given the context and so on, and then leading and then generating a successful attack that can cause the then can cause the target agents to then take malicious actions. So these are the different automatic red teaming that methods that we have developed. So I wanted to also briefly mention that we have been now running a competition. So as some of you may know, I have been running this MOOC, Massive Open Online Course on Agentic AI. We have around 40,000 enrolled globally and so on. And in conjunction with the MOOC, we actually have been running a competition called the Agent Beats competition, which actually focuses on agent evaluation. And we have many thousands have been participating in the competition globally and so on. And one of the tracks is actually on agentic AI safety and security. So the competition is actually now ongoing, and we hope that people can help can help spread the word and have more people join the competition. So that's the first part on the evaluation and risk assessment. And of course, then defense is, as we understand and discover vulnerabilities for agentic AI systems, also it's important to develop effective defenses. And there's no one single silver bullet for effective agentic AI defense. What we need is defense in depth, and also following the general defense best practice. For example, with least privilege separation, safe by design, secure by design, and ideally develop privileged secure systems and so on. So again, in our overview paper, we actually have provided also a comprehensive study analysis of the overall agent defense space. And given the interest of time, I won't have time to go into it. I wanted to just briefly mention one of our recent work called the Project, which is a programmable privilege control and guardrail for agents. It's the first work that actually enables this programmable privilege control with contextual security. So in this case, the Project actually monitors the agent behaviors, for example, tool calls, and also sees the user requests and so on. It then actually dynamically generates policies. So given that a general agent may have a lot of privileges, given that it needs to do a lot of different tasks, but once the user provides a specific task, then for the agent that actually needs to execute this task, actually doesn't need that many privileges. So ideally, you want this agent to then have the least privilege that's needed to execute a particular task. So this is what we do with this with Progen is that we dynamically generate these policies to reduce the privileges that's needed by the agent, and then hence to enable contextual security with least privilege. So that's the first part of building secure agentic AI. I think Leo is showing that I don't have much time left. I'll just briefly mention. So the second part is how we can mitigate misuse. In particular, try to understand the impact of frontier AI on the landscape of cybersecurity. So the part I really want to talk about is we have been developing these benchmarks to really evaluate the the fast progress of frontier AI capabilities in cybersecurity. So here I'll just give a couple examples. One is our work on Bounty Bench, where we developed a benchmark with essentially for web applications. These are from real-world bug bounties, and that covers essentially most of the OWASP top 10 risks and so on. And then the question here is, so we gave the benchmark to the bounty task to agents. The question is whether agents can actually detect vulnerabilities, exploit them, and generate patches. And our work showed that, AI is moving really fast. So this result is from last year. Even for last year, the agent was already able to solve many of the real-world bounty tasks and was able to essentially claim bounties worth of tens of thousands of dollars. So essentially, you can use your AI agents to actually make money by solving these bounty tasks. And now I think it will be even, the capability is even stronger as what another of our benchmarks shows. So another benchmark is CyberGym, which contains close to 200 large-scale, widely distributed open-source software with over 1,500 previous known vulnerabilities. And we give the agent task to essentially two types of tasks. One is to identify previously known vulnerabilities, and the other one is to find 0 days. So with our work, we show that, again, some of the numbers is from last year, and we have some of the latest results here as well. So basically what you can see is essentially there is a straight line going up in terms of, one is the success rate for agents to find, to discover previously known vulnerabilities and also generate POCs, proof of concepts. So these are inputs that can actually trigger the vulnerability. And the other dimension is to find 0 days. So our work showed that the agents can also find 0 days previously unknown vulnerabilities in this large-scale, widely distributed open source software. And again, they have been, the capability has just been going up, yes, with really fast rates. And our work has been included in the system card for many actually Frontier AI Labs latest model release. This is an example from Anthropic's model release, and in the latest Opus 4.6, it's also included there as well. So with that, I think the question is, what can we do? And also, I think the challenge here is that given the natural asymmetry between attacks and defense, it's not sufficient to just have AI, to just rely on AI finding vulnerabilities and hoping that defenders can patch the vulnerabilities before attackers. So with that, we have launched this, we call Frontier AI Cybersecurity Observatory as a central place to that we have collected the various AI in cybersecurity benchmarks. We hope this can be a central place for the community to come together to to continue to monitor AI capabilities in cybersecurity. And also in terms of defenses, I do strongly believe that we hope the best solution is to use AI to help us develop secure by design, safe by design systems that's actually provably secure. And in particular, as we all know, that the holy grail is if we have formally verified systems, but these are largely labor intensive. my group has been among the earliest to use deep learning for theorem proving. So this actually is a paper with Ilya from OpenAI back then, like 8 years ago, which even back then we showed that deep learning can be effective for help automating certain steps in theorem proving. So now with Frontier AI, this is our recent paper where we laid out a roadmap to show that now we are hitting an inflection point where we can really use Frontier AI to help advance and automate formal mathematical reasoning and theorem proving. And we hope that using this approach, we can, instead of just generating code, we can actually generate both the code and also the verification for the code to, in the end, to be able to generate provably secure code. So, so towards that goal, we have been developing techniques and also comprehensive benchmarks on verifiable code generation. So Verina is an example of a first of its kind for comprehensive benchmark on verifiable code generation, where the benchmark includes the evaluation for both performance for models generating the code and generating the spec, and also generating the proof that the code satisfies the specs. And the model's capability on proof generation actually has been limited, but however, with the recent advancements in some of these new models focus on formal mathematical reasoning and theorem proving, there has been huge increase in this as well. So with that, I hope you have learned some information about both the two sides, building both for building secure agentic AI and also for how we can try to mitigate misuse. So with that, I just want to conclude with, so as I mentioned, I'm a faculty director of a campus-wide center called Berkeley RDI, Berkeley Center for Responsible Decentralized Intelligence. And for example, the MOOC and the competition that I mentioned all has been hosted by Berkeley RDI. And last year, we hosted the Agentic AI Summit at Berkeley with over 2,000 in-person attendees and over 40,000 joined online. And this year, we are hosting it at Berkeley again. And we expect over 5,000 in-person attendees and hundreds to join online and so on. So we have a call for, call for talk proposals online. And so we welcome you to both sign up for the summit. The registration, early bird registration is ongoing, which will end very soon. And you can submit your speaker application online as well. And also late last fall, we also organized a workshop on Frontier AI in cybersecurity, risks and opportunities, where we had over 5,000 joined online. So for more information, you can check out the workshop recording as well. I talked about the MOOC, and I hope that you can join the competition as well. Right. With that, thanks everyone.
Do we have any questions for Don? Maybe I can kick one off. So now you've done both the red and the blue. So for folks building harnesses, which is some of the people here, if you were going to just pick like one or two areas that, hey, this is the defensive technique for building an agent, like, and especially like a full-blown agent that you think would be best areas to focus on, right? Where would you encourage folks to, like, which defense, like you were talking about defense in depth for hardening agents. Which methodology or where would you recommend people to focus most on?
I see. Okay, that's a very good question. So essentially, as I mentioned, there's no single silver bullet for effective defense. We really need defense in depth. So I think as you build agents, it's really important to think about to take this defense in depth approach. And also, I would say agent architecture with security architecture is really important. So that's why we talk about, for example, privilege separation. So essentially how you actually architect your agent to essentially limit the, for example, both for these privilege principles and so on. And of course, some work that I mentioned that these, for example, projects and so on can help you to dynamically enable this privilege as well.
Do we have any more questions for Don? Jaime, let me give you a...
So do you think there will be, I mean, what is your thinking around as models get better, will there be a point where like prompt injection safety will be part of the model, or, you know, what are your thoughts around that?
That's a very good that's a very good question. So certainly yes, I think as model gets better, certainly it can be helpful as well. So there's a work that I didn't get to talk about. So in our recent work called the prompt armor, we actually showed that you can use this model to try to essentially observe the the target model's behaviors, and then you can try to detect, for example, whether both the inputs and outputs to try to detect prompt injection attacks. So it's very interesting that like our work showed that if you just currently if you just use the model itself directly, the prompt injection attack can actually succeed. But if you use another model, or even the same model, if you let it reflect and see whether there's attack happening, it actually can detect the attack. So essentially these models with their reasoning capabilities and so on, so they are improving in their understanding of the prompt injection. So when we compare different models, so certainly the later models, more capable models, and also I think they have been probably fine-tuned with post-trained with this type of data and so on as well. So yes, the capability has been improving.
Oh, great. So Victor?
Yeah, thank you, Professor Song. And then my question is actually quite practical regarding to the guardrail problem you mentioned, right? So, so when we do like for example, we asked recently like the GPT-5, the latest model, hey, can you write exploit POC for a DeFi? It stopped answering for those questions. So how does your team? I mean, I'm sure like when you deal with CVEs and all these exploits and all that, you have to deal with that problem a lot, right? So what's your best practice on bypassing the guardrail for that?
That is a very good question. For the latest model, we experienced that as well. So when you run that on the benchmark, actually, I mean a percentage fails. So, but I think although the issue is that, of course, you can do jailbreak and so on. So attackers, it's always, right, there's a cat and mouse game. So attackers can do jailbreak. It can also like decompose the problem into different sub-problems and so on to try to bypass. But yes, I think it's, on one hand, it is nice to see that these models put more of these safety guardrails in. But on the other hand, it does make other, maybe some security researchers are like, white hat researchers want to use a model to do their legitimate work. I think the challenge is that maybe these people, then they can't do their legitimate work, but attackers can still do jailbreak. So I think there are still challenges. But yeah, thanks. A very, very, very good question. Yeah, yes, absolutely. We have seen that.
I have a follow-up on that then.
Okay.
Have you been exploring like ablating models to disable their safeguards? I've seen some papers coming out about new tools that basically disable the safety circuits of AI models for anything that's transformer based. Have you played with any of those new techniques such as Heretic and a few of the others?
I see. So I mean, so first of all, like if you talk about like open weight models, then in general, you don't even need very complicated, sophisticated techniques. I mean, there has been work showing, right? Like even if you just fine tune these open weight models a little bit, then they actually lose their alignment and so on. So overall, it is very challenging to try to protect these open weight models from like their alignment being removed. We have some joint work with other collaborators try to harden these open weight models, but overall it's still open challenge.
All right. Well, thank you,